Okay, the last attribute type for this training series is going to be the complex profiles. That can be found under the Options and Profile Manager. That pulls up this dialog that allows you to pick a complex profile and apply it or edit it. So the complex profiles, as you can see here under this particular profile, can be applied to walls, beams, columns, railings, and then it says library parts, but really that's sort of sub-stair parts or subparts to the stair tool. Things like rail nosings and stringers and things of that nature. So looking at the column tool, for example, we looked at this in Series 1, but we have the segment options and this custom profile icon right here, and that can be any profile in the profile manager that has been designated to be used with the column tool. For a specific example, if I look at, let's go to a railing here, for example, and let's go edit. I just want to showcase one reason why we sort of limit what these are used for. So if I say that this can be used with the beams or walls, and let's go ahead and close out of that and save. The reason to avoid using custom profiles with walls is that walls don't generally miter, they cope or they notch out of each other. So if I apply this to the wall versus, let's compare that to a beam using the same profile. Oh, I think that these are sloping beams. Let's adjust that here. Nope, those are horizontal. Oh, you know what? It's a non-intersecting layer, I think. There we go. So we'll go ahead and apply that to the beams as well. Now this is a profile with a lot of curves to it, so we should see the difference right away. Here are the walls. Let's just put these side by side. It's really critical where there are junctions. So I'm going to put that right there, and then we'll see when we isolate these out that for the beam tool versus the wall tool, we get different junction types. The beam gives a nice 45 miter. The wall kind of copes out, and this adds actually a deceptively high number of polygons and complexity to the model processing. You can see even like this under piece right here, how that's coping together and all of the notching in various ways. That tries to find a clean intersection between those two walls. That has caused problems in other projects on really complex curved or large custom profiles applied to walls. So wherever possible, we should avoid applying custom profiles to walls. As far as managing, editing, creating custom profiles, I have this generic crown molding. This is a very common use of the profiles. And the profiles, if I look at the editor here, are just extrusions of fills. Those fills are building materials similar to the composites, but the difference is in the fill tool here, I can define multiple profiles, complex shapes. If, for example, I had like a ceiling board piece on as part of this crown buildup, I could say that this is 5.5 inches and negative 0.75 inches. I can add in a piece of cove molding here. Try to be as quick as possible with just demonstrating this. Right, and then this is the crown molding profile. It can be, you know, in the case of some of our remodel projects in San Francisco, some of these profiles get really built up and complex. The origin or reference line of this profile is the 0, 0 point. That's this point right here. If I move this off to the side, it actually shows up kind of with that red surface right there. There are modifiers in the profile. There's stretch modifiers I can see right here, but I can also apply those so that the profile can be stretched in the model. It does stretch it proportionally. So like if I change this width in the beam settings from 6 1/4 to 8, all of these distances here to here, the thickness here, all stretch proportionally. If, for example, I wanted this ceiling plate to be adjustable, or sorry, the wall plate to be adjustable, what I can do is add additional modifiers. So I could say, for example, this is, let's put this as wall plate height. We'll go ahead and say OK. and we could say that this piece is going to stretch from that point to this edge. That's going to give a unique modifier for that edge to stretch down independently of the total size. As another example, just to reiterate as well, let's do ceiling plate width. And then click right here to add from this point to this edge has a modifier of that distance. So once I make those changes, all I have to do is simply say save, and let's take a look in 3D at how that looks. So wait for it to finish processing here, and let's go back to our beam tool and apply this profile to a couple of beams. Select those and say apply. You could also change the structure here or in the beam settings to use that profile. So now that profile is wrapping around the corner. Let's just show as an inside corner as well how that all shows in 3D. So we get that profile appearance applied to the beams. And you can see I get that nice 45-degree miter. I also get these extra blue elements, so that gives me a pet palette option for stretching this thing out or back in here as well. Those are those modifiers that we created. You can also, because I set the beam to be modifiable as a whole, if I said that this is, for example, 1.5 feet thick, what you'll notice is that the whole thing stretches out. So if I needed it to be 1.5 thick, but only at the ceiling plate, I have to have those additional modifiers to make that work. You can see that this here then doesn't like to trim out to the other beam because it's trying to trim out here as well. So that's something that also needs to be sort of navigated. Sometimes it makes sense to break these out into separate pieces instead of having one big complex profile if that's the level of control that we need. Additional settings on the custom profiles that are worth mentioning. If we right click and say edit that profile, it'll pull up the profile editor automatically. You can have additional hotspots. So the hotspot tool, if I wanted to add a snap point at the end of the beam right here, for example, I add a hotspot right there, and then there's a snap point. Or I can have a snap point, like I said, if I needed the ceiling to have an option of, let's say, 1.5 feet thickness, putting a hotspot out here at 1.5 feet is going to give me the ability to stretch that to that point really quickly without having to figure out what that extra width is going to need to be. So if it's like option A, option B, option C, I could even pull this back 6 inches and give multiple options there. Additionally, if there are segments of a profile, even within a single fill, that I need to have a different surface for, I can click here on the pet palette and override the surface of this to be, let's just make something that stands out, green there, and adjust this one, make that green here as well. And then to meet our graphic standards, if I wanted to adjust individual line segments to be a different pen weight. So for example, I want these to show as pen 21. And you can meet our graphic standards that way as well by just selecting certain segments, adding segments, making those segments change line weights for different pen sets. So you can clean that up a little bit nicer. The pens don't have to go away, but they will be that pen weight for that section. These do have to be fills. The fills do have to be building material fills. Any line work that you put in here is not going to be extruded because it's not part of that extrusion. It may add some extra hotspots or extra dimensionality to it in the settings, but it doesn't add any geometry to the 3D extrusion. So now if I save and close, then we're going to see those changes affected globally for this profile. Well, once we eliminate the surface overrides in the beam settings. Custom profiles are one area that I don't actually use model overrides for this exact reason, because I want to see these different surfaces being applied. And then here's these extra hotspots that I mentioned before. So now if I grab this piece and on the pet palette, I can stretch this to this point and snap exactly to one of these points. So that is creating custom profiles. And again, making sure, just like with the composites, that we're setting this to be applied to the correct tool. So in this case, because it's a trim element, I don't want that to be available for a wall. Because it's a crown molding, it probably doesn't need to be applied to a column. So it's really only for the beam tool. There are also additional catalogs of custom profiles in ArchiCAD. If we go to Options and Complex Profiles, take a look at the Profile Manager here, or sorry, not the Profile Manager, the Complex Profiles, and Import Standard Steel Profile. There's a whole catalog based on countries that ArchiCAD's available for. There's Imperial, US Metric, and they're based on these shape names that are not actually standards, but the 8 shapes are the various wide flange shapes available. If you have to import a steel profile, you can actually grab multiples and say add to profile to the project. If I have hollow steels, square steel, round steel, really I don't know that I've ever had a steel profile that I couldn't find in these catalogs. Once I have those, I can select them from the list, change the building material, not to water, but to steel, and then say import. Those are now going to show up available in my profile manager. It is important to do a little bit of cleanup on these profiles after you import them. So you can rename them so that they follow the naming convention. I think that the standard for a template is STL and then that little vertical line. You can hit rename right here so it follows the naming convention, STL, and then it's going to fall in line with the rest of those steel profiles. But then I also need to edit this because the default pens, out of the box template pens for these boundary pens are not going to show with the correct pens. We do want to show those with the structural pen. So we switch that pen here, and because this profile has been edited with individual edge adjustments, I want to apply to the custom edges as well as the default edges and say OK, and then that's my default fill. Additionally, the profile library, importing those steel profiles, likes to add hotspots to all of these points. If I move these off to the side so you can see, and very rarely do we need to snap to all whatever half dozen or dozen of those points. So I'll typically eliminate those and only add in hotspots where I need them. Additionally, the standard origin for any imported steel profile is essentially the center of mass, the X and Y center of that profile. So if it's a beam element, it might make sense to shift that down so that this is actually, that reference line is at the top of the beam by default. If it's primarily a column, it can be centered up still. If it's beams and columns, you sort of have to use your discretion on the best way to apply that profile. The other thing to note here is that the standard heights for a lot of these steel profiles include 32nds and 64ths. So if you're placing this beam, like say to align to a top plate, just know if you're dimensioning the bottom of that beam, you're going to see 32nds pop up in your dimensions on the sections and elevations. So we do have to be kind of careful about where we're snapping to. If you see 64ths, it's not an uncommon practice to actually stretch this down a 64th or 32nds of an inch. It really depends on the level of precision, what you're going to be dimensioning to. If you are going to adjust this profile, always adjust big. It's better to obviously have it bigger than it's going to be than smaller, so we know that we've got more room than less. But generally speaking, as long as we're careful about what we're dimensioning to, this is a pretty precise profile. It doesn't usually include things like the coping where these are connected, so if you did need that extra little bit there that often shows up in steel profiles, you may need to add that in here as well, because they are sort of dumbed down, trying to make it ideal for polygon management and not level of detail. You're never going to see that little bit at 1/4 inch scale, and if you're looking at it at a detail scale, you can add that in the details, but that is something that doesn't happen in the profile manager very often for many of the profiles, is eliminating those little curves and stuff. So adding those in can be useful. And then once I get that done, I can just say save, and it's ready to be applied to beams and columns. If that was going to be part of a stair, say the center stringer of a stair, I would have to also add that as part of the object profile. Or if it was going to be the base rail for a railing, I would have to add that to the railing. Again, there's not a lot of use for custom profiles within walls, or if they are useful, generally speaking, it's more problematic than helpful.